All right, let's start with a warm-up problem. We're going to graph the quadratic y equals x squared plus 4x minus 5. First of all, we want to find the axis of symmetry. The axis of symmetry is the equation x equals negative b over 2 times a. In this case, a equals 1, b equals 4, c equals negative 5. We look at the a, the b, and the c. So here x equals the opposite of 4 over 2 times 1, so that is negative 2. I'm going to graph my axis of symmetry. So the vertex sits on that line. Now I want to find the vertex. I know it is, the x-coordinate is negative 2, and I need to find the y-coordinate. So I plug negative 2 in for x into my original equation, that is negative 2 squared, plus 4 times negative 2 minus 5. That is 4 minus 8 minus 5, that is negative 9. So the vertex is negative 2, negative 9. So here's my vertex, and then I have a is 1, so I have the shape of the parent graph starting down here. So I go out 1, up 1, out 2, up 4, out 3, up 9, and here's my parabola. Now let's take special note at these x-intercepts. This is 1, 0, and this is negative 5, 0. If we come back to our equation and factor this equation factors to x plus 5, x minus 1. So the 0, negative 5 plus 5 is 0, and when x is 1, 1 minus 1 is 0. We're going to be interested in these x-intercepts today. So this is what we're going to do today. We're going to solve quadratic equations by graphing and using square roots. The solution to the quadratic equation, ax squared plus bx plus c equals 0, those are the x-intercepts. So the solutions to this equation are the x-intercepts of this graph. These are called the roots or the zeros. That is, the x values when y equals 0. So looking at this graph, we have y equals x squared minus 4. That's our parent graph, and we translate it down to 4. So we start at 0, 0, and we bring it down 4. Now it crosses, it has x-intercepts at negative 2 and at positive 2. So those x-intercepts, 2, 0, and negative 2, 0, are solutions to the equation x squared minus 4x equals 0. Now let's remember how we factor x squared minus 4. That factors to x plus 2 and x minus 2. And we see that when x is negative 2 plus 2 is 0, and when x is positive 2 minus 2 is 0. So let's look at these examples. When I want to solve x squared minus 1 equals 0, I graph y equals x squared minus 1. That graph is the parent graph shifted down 1. And I have two solutions. This equation, or this quadratic factors, x plus 1, x minus 1. And my solutions are at x equals negative 1 and x equals positive 1. To solve the equation x squared equals 0, I look at the graph of y equals x squared. That has one x-intercept at 0, 0. To solve the equation x squared plus 1 equals 0, I look at the graph of y equals x squared plus 1. That's our parent graph moved up 1. So there are no x-intercepts. That means there are no solutions. So this equation, x squared plus 1 equals 0, has no real solutions. The graph has no x-intercepts. We're going to solve this equation and graph the related function. The related function is y equals negative x squared plus 4. We could also look at that as, that's a parabola that opens down and then is up 4. So when I graph that, I move up the y-axis to 4, and then my parabola opens down. Out 2, down 4. Out 3, down 9. Here are the x-intercepts, negative 2, 0, and positive 2, 0. Solving this equation, I'm going to say, well, 4 equals positive x squared. I add x squared to both sides. And now x equals negative 2 or x equals positive 2. And I see that these solutions correspond to the x-intercepts, negative 2, 0 and positive 2, 0. We could also think of factoring y equals 4 minus x squared. And that factors to 2 plus x and 2 minus x. When x is negative 2, 2 minus 2 is 0. And when x is positive 2, 2 minus 2 is 0. The equation 0 equals 3x squared minus 27. The related equation is y equals 3x squared minus 27. That graph is a stretch by 3 and then slid down 27. I'll put some axes on this graph. So this graph starts down at 0, negative 27. And instead of going over 1 and up 1, it's a stretch of 3, so we go over 1 and up 3. Then over 2 and up 12, and over 3 and up 27. So that's going to be all the way back up at . So here's the parabola. The y-intercepts are at, the x-intercepts are at negative 3, 0, and positive 3, 0.
Elijah Beeston, please come to the main office. Elijah Beeston, please come to the main office.
To solve this, I'm going to add 27 to both sides. So 27 equals 3x squared. Now divide both sides by 3. 9 equals x squared. So we see that x equals 3, or x equals negative 3, corresponding to
Jessica Graham to the main office, please. Jessica Graham to the main office.
Our x-intercepts. So this is the relationship between the solution and the graph. We see that the solutions on the graph are the x-intercepts. On this equation, I'm going to solve it directly. I have 4x squared equals 0. The related equation is y equals 4x squared. That's a graph that has a stretch by 4. Has it intercept at 0, 0. When x is 1, y is 4. So the parabola has one x-intercept. The solution to this equation, when I divide by 4, x squared equals 0, so x equals 0. And the y-intercept is at 0, 0. In the second example, the related equation, or the related parabola is y equals negative x squared minus 1. That's a parabola that opens down and shifts down 1 unit. So this parabola has a y-intercept at 0, negative 1, and opens down. This has no x-intercepts. That means the equation will have no solutions. This is negative x squared equals 1 when I add 1 to both sides, or x squared equals negative 1. Well, x squared is always positive. It will never equal negative 1. So to solve equations of the form ax squared plus cx equals 0, that is, when b equals 0, there's no b term, these equations can be solved using the square root. And this is how we do it. You're going to isolate your x squared term, so I'm going to add 25 to both sides. Then I have x squared equals 50. Now I take the square root of both sides. And when I put the square root sign there, I have to put the plus or minus. So this tells me that x equals plus or minus square root of 50. So that is x equals minus 5 square root of 2, or x equals plus 5 square root of 2 in simplified radical form. Because square root of 50 equals square root of 25 times 2, and the square root of 50 is 5. In the second example, I'm going to add 75 to both sides. So you isolate your x squared term. Now I have 3x squared equals 75. I will divide off the 3. That leaves me with x squared equals 25. So x equals negative 5, or x equals positive 5. You take the square root of both sides, and when you take the square root, when you put the square root sign there, you must put a plus or minus. In the next example, I'm going to add negative 15 to both sides. That leaves me with 3x squared equals negative 15. I'll divide both sides by 3. Now I have x squared equals negative 5. But again, x squared is always positive. It will never equal negative 5, so there are no real solutions. Thinking about the graph, plus 15, our graph is slid up 15 and then opens up from there. So the y-intercept for 3x squared plus 15 is at 0, 15. So there are no x-intercepts. That corresponds to no real solutions. The final 3 examples, isolate x squared and take the square root of both sides. Add 15 to both sides. That leaves me with 5x squared equals 15. Divide by 5. X squared equals 3. Take the square root of both sides, and when you put the square root sign, you must put the plus or minus. So x equals negative square root of 3, or x equals positive square root of 3. In the next example, add 72 to both sides. Then you have 2x squared equals 72. Divide both sides by 2. So x squared equals 36. Take the square root of both sides and include the plus or minus. So x equals 6, or x equals negative 6. Finally, subtract 2 from both sides on the last example. That leaves you with 7x squared equals 28. Divide both sides by 7. So x squared equals 4. Now you take the square root of both sides, include the plus or minus, and x equals 2, or x equals negative 2. The corresponding x-intercepts on the graph would be 2, 0, and negative 2, 0.